Right now, if you want to store the solar energy your panels make during the day, you have exactly one option that anyone will sell you. Bolt a lithium battery to your garage wall and write a check for $15,000. And that battery starts dying the moment you plug it in. But there is another way to store that same energy in a steel tank that costs around $90, holds full capacity for 30 years, and never degrades. No lithium, no cobalt, no warranty that expires. It is called compressed air energy storage, and the physics behind it were settled more than 360 years ago. By the end of this, you will know exactly what it is, how it works, and how to build one yourself in a weekend. So let's get into it. First, let's look at what that lithium battery is actually doing to your wallet, because until you understand the trap, you will not appreciate the way out. The most popular home battery in America stores around 13.5 kilowatt hours of energy. Installed, it runs somewhere between $15,000 and $16,000. And the manufacturer guarantees that after 10 years, it will hold just 70% of the capacity you paid for. Now, understand what that means. That is not the failure point. That is not the worst case. That is the promise. 70% is the floor they are comfortable putting in writing. Independent testing centers that track real-world degradation, cycling these packs one charge per day, have measured capacity losses of around 20% after roughly 2,500 cycles. Do the math on that. That is under 7 years. 7 years and a fifth of your investment has simply evaporated into chemistry. And here's the part almost nobody hears until it is too late. Some of these units require a continuous internet connection to a company server to honor the full warranty. Lose that connection for too long, and the guarantee can shrink from 10 years down to 4. Think about that. You are spending $15,000 on a storage device, and it needs permission from a computer in another state to keep its own promises to you. Now let's talk about the replacement math, because this is where it gets ugly. When that battery hits 10 years and sits at 70%, nobody sends you a refund. You buy another one, another $15,000. But your solar panels are warranted for 25 to 30 years. So over the life of your own roof, you are looking at 2, maybe 3 battery replacements. That is $45,000 to $60,000 in storage alone, just to use the electricity your own panels already made for free. And every one of those dead packs becomes hazardous waste. Lithium-ion cells cannot go in your regular trash. The lithium itself is strip mined from open pits in the deserts of South America and hard rock operations in Australia. Refining it consumes roughly 500,000 gallons of water per ton extracted. Then it is shipped across an ocean to be assembled into cells, shipped again to reach your driveway, installed in your garage, and in 10 years, hauled away to a waste facility so the entire cycle can start over. Right now, fewer than 5% of these batteries in this country ever get recycled. The rest sit in landfills or in hazardous storage forever. That is the system we are told is the only road to energy independence. But there is a way to store energy that uses nothing but air and a steel tank. No chemistry, no rare earth metals, no degradation curve at all. And the principle behind it has been understood since 1662. It is called Boyle's Law, named for the natural philosopher Robert Boyle, who described it over 360 years ago. And it is one of the most fundamental rules in all of physics. When you shrink the volume of a gas and hold the temperature steady, the pressure rises in proportion. Squeeze air into half the space and the pressure doubles. Squeeze it to a tenth and the pressure climbs tenfold. And here is the beautiful part. That pressure is stored energy. It does not decay. It does not degrade. It does not need a firmware update or a Wi-Fi signal or a subscription. The air simply holds its charge, quietly, until the day you decide to let it go. So here is how the whole system works. During the day, your solar panels run a standard electric compressor. That compressor pushes ordinary air, the air all around you, right now, into a pressure vessel. In this case, a repurposed steel tank rated for sustained high-pressure service. When the sun goes down and you need power, you crack open a valve. The pressurized air rushes out through a small air motor. That motor spins a generator, and the generator makes your electricity. That is the entire machine. A compressor, a tank, an air motor, a generator. 4 parts. No lithium chemistry, no risk of thermal runaway, no cell balancing software, no fire suppression system bolted to your wall. And there is a second principle that makes this even better at the scale of a single house. It is called the ideal gas law. When you compress air, the molecules pack together and the temperature rises. Now, in a lithium battery, heat is a danger, something you have to fight. But here, that heat is a gift. Run the compressed air through a simple coil of copper tubing sitting in a water tank, and you route all that compression heat straight into your hot water supply. And when you later release the air to make power, the air comes out cold. That cold can be ducted into your living space in the summer or pointed at your refrigerator. This is called polygeneration. One single cycle gives you heat and cooling and electricity. 3 outputs from one machine, all from air. And this is not a chalkboard theory. Researchers in Italy tested exactly this setup, storing air in a vessel no larger than a standard water heater. That one small tank captured around 96% of the excess solar energy off a residential rooftop. A separate team in Poland built a working prototype and published their measurements. They worked a round-trip electrical efficiency near 65%, producing over a kilowatt of continuous power. That is enough to run a refrigerator, your household lights, a phone charger, and your internet router, all at the same time. And every single researcher who tests these systems reaches the same conclusion about the tank: zero capacity loss. Zero. A steel vessel has no cycle limit. It has no calendar life. It does not degrade from temperature swings because it is not holding a chemical reaction. It is holding air, and air does not expire. Now, if you think this sounds like some fragile little experiment, let me show you where compressed air has already been proven, at a scale that should stop you cold. Back in the 1850s, engineers cutting a rail tunnel through the granite of the Alps used pneumatic rock drills powered by compressed air. Those drills increased their progress from about 60 centimeters of rock per day to 2 full meters per day. Compressed air punched an 8-mile hole through a mountain in the most brutal conditions imaginable, and it never let them down. Then, in 1978, in Lower Saxony, Germany, engineers switched on the world's first commercial-scale compressed air energy storage plant. It stored air in underground salt caverns and put out 290 megawatts of electrical power. And here is the number you need to hold on to. That plant is still running today. 47 years of continuous operation. Some of its original mechanical hardware from 1978 has never even been replaced. Now compare that to a lithium battery that cannot survive a single decade without losing a third of itself. In 1991, a second plant came online in Alabama, storing air in a massive salt cavern 19 million cubic feet in size. It delivers 110 megawatts for up to 26 hours per discharge. When you work out the cost per kilowatt hour of that storage capacity, it comes to roughly $23. Now compare that to the home lithium battery at around $1,100 per kilowatt hour installed. That is a cost difference of more than 50 to 1. And that Alabama cavern has a projected working life of over 100 years. And it goes back even further, to a story almost nobody in the American energy conversation has ever heard. In 1879, an engineer named Victor Pop built a compressed air network beneath the streets of Paris. It started by driving pneumatic clocks, synchronized by pulses of air through underground pipes. But it grew and grew, until it was powering elevators, lathes, sewing machines, and beer pumps across the whole city. By the middle of the 20th century, that network served nearly 10,000 customers, and it ran continuously for 115 years, from 1879 all the way to 1994. And listen carefully to why it finally closed. It did not close because compressed air stopped working. It closed because local industry declined, and maintaining the aging pipes was no longer worth the money. The technology never failed. It was simply outlived by the economy around it. So think about what we have here. Proven at utility scale since 1978. Proven at city scale for 115 years. Proven in laboratories again and again with zero storage degradation. So why then can you not walk into a hardware store and buy a compressed air storage unit for your home? And here is the honest answer. The barrier is not performance. The barrier is paperwork. Every financial incentive in the American energy storage market was built around lithium-ion chemistry and nothing else. There is a 30% federal tax credit for home battery storage. On paper, a compressed air system should qualify because the rules simply say the system must receive, store, and deliver energy for conversion to electricity. And that is exactly what compressed air does. But in practice, that credit is out of reach. No manufacturer has gotten a safety listing for a home compressed air product. No installer network exists to certify it. No permitting office in any major city has a pathway written for it. And without a listed product and a licensed installer, no tax professional will put it on your return, and no appraiser will add $1 of value to your home for it. So look at what really happens. The homeowner who buys the lithium battery gets the 30% credit, a turnkey install, recognition in the appraisal guidelines, and an insurance rider. The homeowner who builds a $500 compressed air system out of a steel tank gets none of that. No credit, no appraisal bump, no rebate, no coverage. National laboratories have researched this technology for decades. Government agencies have funded feasibility studies on small-scale community versions. And not $1 of that research has ever turned into a product you can buy off a shelf because the entire system was designed around batteries, and anything outside that design is simply invisible. And in a market ruled by tax credits and certifications, invisible is functionally the same thing as forbidden. The American home energy market does not reward the best technology. It rewards the technology that fits inside the existing paperwork. And right now, that paperwork has exactly one shape: lithium. So let me show you how to build one yourself. Because the paperwork can ignore you, but it cannot stop you. The heart of the system is the storage vessel, and for that, you want a certified steel pressure tank. A steel propane tank, built to the mechanical engineering standard, is made from thick steel with strong welds, and it is certified once at the factory for the life of the vessel. That life routinely runs over 30 years with zero structural maintenance. A brand new 120-gallon vertical tank runs between $400 and $600 retail, but a used or decommissioned one from a propane company retiring older inventory can be had for $50 to $120. And understand the margin you are working inside. These tanks were built to hold liquefied propane at 250 pounds per square inch, sitting in direct summer sunlight. Holding compressed air at 150 pounds is well within their comfort zone. For the compressor, choose an oil-free electric model, rated for at least 150 pounds per square inch of continuous duty. Reliable units run $200 to $400. And oil-free is not optional, because the air going into long-term storage must be clean and dry. Add an inline moisture separator and a desiccant filter for another $20 to $40. Moisture is the one thing that can corrode a tank over the decades, so you eliminate it right at the inlet, and the storage side then needs no maintenance at all. The air motor is the piece that turns your stored pressure back into motion. A vane-type industrial air motor runs somewhere between $150 and $300. You connect that motor to a permanent magnet generator or a small automotive alternator, and that charges a small 12-volt deep-cycle battery for $60 to $80. Now, hear me on this. That little battery is not your storage. The tank is your storage. The battery just smooths out the voltage at the very end of a discharge and gives your inverter a stable reference to work from. Total cost for a working home-scale system runs between $500 and $1,200. That is 3 to 5% of a single lithium battery install, and that steel tank will still be holding full pressure when the third replacement lithium battery is on its way to the hazardous waste yard. You can build this in a weekend with basic tools: a wrench, a pipe cutter, some thread tape, and a real understanding of how pressure systems behave. But there is one safety rule you must never break. Never use PVC or plastic pipe for compressed air. Plastic becomes brittle under pressure cycling, and it can shatter without warning, throwing fragments at lethal speed. Use black iron pipe, copper tubing, or aluminum pipe rated for compressed air. And install a pressure relief valve on the tank, set to open at 10% below the vessel's rated maximum. That valve costs $8 to $15, and it is the single most important safety part in the entire build. If you plan to run above 200 pounds per square inch, stop and consult a licensed mechanical engineer for your pipe sizing and valve rating. I mean that. Now let me give you the honest limitations, because I am not here to sell you a fantasy. Round-trip efficiency for a basic home setup runs somewhere between 30 and 65%. A lithium battery hits closer to 90, So on a per-cycle basis, yes, lithium wins. But efficiency per cycle is not the same as value over a lifetime. A system that runs at 50% for 30 years produces far more total energy than one running at 90% for 10, because the second one ends up in a landfill, and the first one just keeps running. The second limitation is moving parts. Compressed air needs a motor and a generator, and that is more machinery than a sealed battery. But those parts are rebuildable with ordinary hand tools. A dead lithium cell is not rebuildable by anyone. And the third limitation is noise. Compressors are loud, so if your neighbor's window is close to your property line, plan on sound insulation around the enclosure, or simply run the compression during the daytime when the world is already noisy. So here is where we land. Compressed air energy storage is a 250-year-old answer to a very modern problem. It stores your energy as pressure inside a steel vessel that costs less than 1 month of your electric bill and lasts longer than most home mortgages. And the only reason it is not sitting on a shelf next to the lithium batteries is that nobody can build a recurring revenue stream around a tank of air that never needs replacing. There is no quarterly earnings report for a steel tank that just keeps working. A lot of what this channel digs into lives outside the conventional path, not because it stopped working, but because the money was arranged around the product that costs more, wears out faster, and needs buying again and again. If recovering the lost art of energy self-sufficiency matters to you, subscribing and sharing is the simplest way to make sure this kind of knowledge keeps getting found and passed on instead of buried. So here's my question for you, and I genuinely want your answer in the comments. If you had the roof space for solar and the budget for one storage system, which way would you go? $500 on compressed air that you can fix with a wrench in your own garage? Or $15,000 on a lithium battery that needs a Wi-Fi signal just to honor its own warranty? Tell me which one and tell me why. I read them. And before you go, hold on to one number. That German plant, running since 1978, has never once replaced its storage medium. 47 years.